Good morning. Hello. Happy Tuesday. Hello, Lumicode. How are you doing today? Yes. Hello. Hi. Hi. Come here. Sophie. What is our plan today? Today we're going to try to make it so the humans can't walk past each other. I think that's going to be the main goal, or at least like they hit each other and can't go any like farther inside. So there's going to be a couple things to this. First of all, we're going to have to detect when they're overlapping with each other. Shouldn't be too hard. And then the second thing is, now it's either that we can, let's see, there's a couple different things. I could just have it so they hit each other and then come out, or I can have that they repel each other. That's actually a lot more like a flocking simulation. Let's have it that they repel each other. There's a small radius around them, maybe. So if we open up this, which by the way, I learned of a new thing we can do with terminals. In the zombie simulator, I can come over here and I can actually move this into the editor area. So it's just a full tab in the editor, which is really nice. Basically, it's getting closer and closer to Tmux. All right, so I'm gonna just cargo run this. Okay, so here we have everybody just sort of moving randomly, but they're moving over each other. So first of all, I want this to be a little bit slower. So their base speed is maybe half of this. And then that should be fine. Where should I put this? So let's change their base speed. So that's going to be in main. Speed is 0.5. Let's change that to 0.25. Still feel like this might be a bit fast. How about 0.15? Oh, and see, I don't want to create this terminal. I don't want to use that one. I want to use this. Okay, this feels a lot better. So, okay, then when we want to visualize an area around one of these. So let's just take maybe the first one and we're gonna draw a circle around it. So we can actually create this as a visualization. So, okay, we need like a sight radius. Pretty soon, Clippy's gonna yell at us about having too many things in here. But this is gonna be our human vision range. F32 is fine. I think we're here now. This function has way too many arguments. Okay, so by the end of this, we're gonna need, when we go and clean up all the warnings, we're gonna have to convert this into a config struct, which is gonna be fine. Like a config struct will be fine. But now, if we want to create a resource for like a human vision range, well, everybody has a different range, right? So like zombies are gonna have one range, which I think is gonna be bigger than the humans. And then the humans are gonna have their own range. So this should be a component. So let's find components and add you in here. So this is gonna be vision range. This is going to be human vision range. Let's just make this like 10. See, our size is 5, so that would be double. Maybe 15. Then I'm gonna pass this in here. Okay, and now we can actually add this component. So let's create, I guess they can all have this. So with component, so we're gonna have vision range, and this is gonna be the human vision range. Okay, so now all of our entities have this human vision, have a vision range. It all just happens to be a human vision range, so that's fine. So then I want to visualize that. And I want to visualize it only for maybe like one of the creatures in there. Otherwise, it's probably going to be a little bit too much. So let's go into our systems. It would be for draw vision range. Maybe I'm gonna do this like as visualize vision range. Okay, so for this, we're gonna want our world is world, and we're gonna turn a result. Then, okay, so how are we gonna visualize this? We're going to query for Oh, you know what? Because we're drawing, we're also going to need a context. And I think that's all we're going to need. So we need to get the vision range. We need to get the mesh. No, we don't need to get the mesh. We're going to create the mesh here. But we need to find out if we have like anybody first. No, because I think we'll be fine here. So let's do visualize. Okay, I already want to change this. I want to rename you to visualize human vision range. So the idea is that I'm going to just take the first human and we're going to just draw a circle around them. So let's create our mesh first. Okay, so our radius here. Oh, that's actually going to be the human vision range. So we actually do. Okay, we're going to need to do this for each one of ours. So we do need to do the query first. Okay, so the components we need to get out of here, we need our locations. And we also need this vision range. What else do we need? A location and a vision range. I think that's all I need. Now, everything in here is a human right now. We're probably gonna need to have some kind of like type in here, but I'm gonna hold off until I can know exactly what that's gonna look like. So we're gonna run. So that gives us our query, and extract those out. So I wonder what this code looks like if I don't extract it out and I just like do everything based upon this, which I think I can. So if I just do now in this case, I'm going to create this on the first one only. So okay, what we can do is if let sum, this is going to be a location is equal to query.first, okay. Then query of 0.first. Okay, which gives us this reference to a ref cell. Then so we know that we have that. Now we can I think it's gonna be just a borrowed Location is the replication.borrow. Then borrow division range is going to be query of 1 dot first dot unwrap dot borrow. Close. Oh, and I want this to be 0. So then we're going to do first. We have to unwrap you, and then we can borrow you. Okay, so now I have our location and our vision range. Now I can create our mesh. And I might as well just create it right in the right position, so I don't need to like translate it over. That'll be fine and easy. So let our mesh, it's going to be equal to, here's our mesh builder new. We'll make a circle, a draw mode, stroke, point. Okay, so in this case, we're going to want our, we need to downcast it. I don't think I can do this all together. Let me think about this. So can I, so we borrowed it here. So can I do borrowed location? We're gonna downcast ref into a, I guess it's gonna be downcast into a location. Okay, so that gives me that. Then I want to deref this. Oh wait, no, then we want to unwrap it. Then we want to deref it. Then I want to mint vector 2. That this feels, I'm trying to do this all in one line right here because I only need that at this point. Then radius, this is going to be pretty much the same thing. This borrowed vision range. So borrowed vision range, we're going to downcast ref. You're a vision range. Unwrap you. Then we're gonna deref. I guess in this case, I could just deref here and it should give me, I think I need to do it twice. Once gives me a reference to it, and the other one gives me the actual like position in memory. Tolerance, 0.1, so it's a circle. And color, we could just make this white. Okay, so we have our mesh. Then it's time for us to draw. So all right, so we're gonna just do that to the first one here. Oh, vision range needs to implement debug. We can do that. Okay, so then you're happy. Back to the main library, and let's bring you in and run you. Close. We need the context also. Oh wait, that's not going to be here. we're actually doing this here. Okay, let's try running this now. Let's see. Thread main panicked at called option unwrap on a none value. Visualize human range. Line 32. Oh, so I tried to downcast the borrowed vision range. Well, that wasn't what I thought it was. Let's, you should be there unless, no, because it's so it unwrapped here. So there is something in there. Let's, oh, wait. This should be query 1. That was a location. My bad. Okay. So that would be the vision range of our humans to like avoid each other. I think that's fine. So if they see, well, we should probably have it be a little bit bigger than that. We could have it be double them. So if their entity size is this, let's have the human vision range be, let me think about that. So entity size is a radius. And I want this to be them to be able to fit someone in on each side of them. So that would be basically double the entity size and then double that again. So times 4 essentially. So what if I just set this to entity size times 4? So they might still bump into each other, but I think it'll be it will, I think that'll be fine. Humans can have been known to bump into each other in the past, so that's good. Lord Mist, hello. How are you doing today? Okay, so then what I think we can do is we can work on the repulsion of humans from each other. You're doing great. Awesome. That's great to hear. Now, I don't have any like really great systems for this. If we were doing like a grid-based location, then we could like only query nearby, you know, humans, but we're gonna have to query all of the humans and then get the distance to them, which is not super great. So let's think about this. For every single one of these, get a list, then query through all the other ones. Yes, I have been working on ECS. We've implemented Utspi's bitmap system, although I don't know if I did it correctly. I'm gonna have to like go back in and like re-look at that after I've got all the basic features running to see if I want to like make that any better and any cleaner. And it's totally fine. I fully understand. So the chat, really? Yeah, I switched that out a little while ago. I saw how was it? I saw like some of the features. I actually went through them and like switched um switched to a new one that came out. So I'm liking it. Okay, so for every single one, then find the distance, so the magnitude between the two locations. And then if they're within the sight range, then create a force. And it probably can just be like a static force. Just create a force in the other, in sort of like the opposite direction of that. I don't know what that static force should be. That should probably be a resource. All right. Well, let's start with this, and we'll see how far we can get. Okay, so I'm gonna begin with. So it's less of a game; it's more of a visualization. I'm thinking it's gonna be something very similar to the flocking simulator, but instead it's gonna be humans versus zombies. So if a zombie touches a human, then they end up dying. Oh, and this will be perfect because humans are repulsed from everything, right? That'll be fine. Humans have very short vision range, of course. Okay, so we're gonna start by creating a system for this, which is zombies are not repulsed by anything, so only humans. So human, it's like there's attraction and then repulsion. I think human repulsion. All right. Wait, what? How did I? Oh, what's this? That's cool. I did Control Shift dot, and this window popped up. Oh, that's nice. I don't know how helpful that is. Okay, so for each human, in order to like be repulsed from everything that they can see, we're gonna need to see all the other humans. So we're gonna need to query for basically every location. And we also need the entity size, since those are the same across all of them. So let's get the entity size first. Oh, and then we can get... Okay, so we get that out. All right, so once we have our entity size, then I need to query for basically just all locations. And then I think that's going to be it. We just want everything with a location. So then we're just going to run this, and that gives us that. Now, in this case, we could just go for get the first and unwrap this because, I mean, there can only be one. Okay, so we have, this is just the wrapped locations. Then for each location, I'm gonna have to look at all the other locations. Now I could clone this pretty cheaply, and I think that should be fine. So like this is our wrapped locations. They're gonna have like the other locations, but how are we gonna know it's ours? Well, probably the index. That's how we're gonna know. So let's start with like our for loop. So we're gonna do for index locations. Okay, yeah. Wait. No. Close. Okay, so we're gonna do that. What are you upset about? Oh, okay. I was really hoping I could do that, but no. That's fine. So make this a query. Then what we'll do is wrap locations. So we'll just do first. Wait, this is query. So query first, unwrap And actually, I could maybe it might make sense just to do this like that. That gives us that. So then we can iter and then enumerate. Yeah, okay. This is a little bit better to work with. It's still going to be a wrapped location though. Okay, so we have wrapped location and we have the index of this entity. So now I want to check all of the others. So I essentially want to clone. So we're gonna do we basically have like other locations. So this is gonna be our query of position 0, and we're gonna clone it. Which should be fine because it's an RC. So that should be pretty cheap to clone. Then now I want to get the distance between this one and every single other one. So now I want to do another loop. So this is going to be entity index, entity wrapped location, and then we're going to have to do another loop here. So for other index, other wrapped location, in other wrapped locations. Oh, see, it's good except for that final. That final parentheses. Hold on. What if I take out this? What do you see? For other entity index, other replication, in other replications, iterate, enumerate. Okay, so this is a good start. So we do that. Then inside of here, if entity index is equal to the other entity index. Okay, what is your plan? Continue. I think that's correct. We are going to continue. All right. Why are you so upset though? Because I'm missing a closing bracket there. That's why. Okay. All right, so for this then, okay, so now we know we're not the same. We're not looking at the same other location, which means that it's time for us to get the distance between these locations. So let's extract the we're gonna need to, before we do this for here, we need to extract our location into an actual, well, vector too. So let entity location, so this is actually gonna be a borrowed. The location is gonna be equal to entity replication. We borrow it, yes. And then after we borrow it, then we have to downcast it. We are not doing anything with that, so we're just going to downcast ref to a location. We could just unwrap. Okay, that gives us a location. Then I want to probably deref this into the vector too. I don't know if I want to do that there. I think I want to keep this as the location here, and then we're going to deref it for whatever math we need to do at the very end. I realize something that we need for this is we're going to have the accelerations to create the force for this, and our walking speed. So we need to add in to our query. Nope, not there. This query. So dot with components. This is going to be our speed. Yeah, speed is a component. Okay. Okay, with create speed. Then with component acceleration. Okay, so we need to get those things as well. So we're only looking at the first one right now because that's the locations, and that's fine. Okay, so we clone that, and we're iterating through this first one. So this is fine. Peyton Rules, hello! It's been a while since I've seen you streaming, Peyton. How are you doing? Yeah, I mean, I see you every once in a while. It's just recently I haven't seen you. I assume that you're super busy, right? Okay, so we get all these things. Okay, so we continue through. We have our location. Okay, time for us to get the other location. So let borrowed other location. And this is going to be the other wrapped location dot borrow. Okay. So that gives us this ref dyn any. So we need to downcast it. So then we're okay. This looks right. Okay, so now we have two locations. We have our location and the other location. So now I want to get the distance between the two. All right, so we're gonna need to do that calculation ourselves. So we need to go into our vector 2 here. and add in that. So how do we get, oh, you were supposed to today and your buddy said, nah. Well, thank you for hanging out with us, and hopefully you're feeling up to streaming soon. Let's see. So I need to remember how to get the distance. Okay, distance is that just magnitude? That's like a squared plus b squared equals c squared. Yeah, I think that's it, right? So it's okay. So we're gonna get up function distance. So okay, I'm actually curious about this. Let's create this. Get the distance. Oh, get the length of this vector. Get the magnitude of this vector. Okay, so pub function magnitude self. Okay. Where are you going with this? Hey, look at that. Okay, so let x equals self.x, y equals self.y, square root of x times x plus y times y. All right. There's that first one actually seems like it's good. Now, what about these other ones? Can we make this a little bit more rusty? The x squared. Okay, so you could break it out extremely small. And then just variations on the exact same thing. What is this doing? Square root. Okay. So you know what these solutions look like? These solutions very dystopian. Yes, absolutely. Also, hello, Selective Duplicate. These solutions look like a junior programmer who's, I guess, not even a junior programmer. Someone who's like read a textbook on like programming, but not actually coded before, just like knows some math. And then I asked them to solve this problem, and I said no to the first solution, which was actually perfectly fine, and then their decision was just to add more lines of code, because maybe what I wanted was just more characters. Oh, this is like it's got the right idea here. AI use cases like this really scare you. I think like they're scary if you don't watch them, to me. But I don't like. I think they're going to be great as human companions in order to like build things faster and better over time. So what I'm thinking is we can try to we could probably use like the power thing. So we can do this in one line here. So that's what I want to do. I want to do this in one line. So we're going to do the square. Oh, and square root isn't like part of that thing. It looks like your code from 6 years ago. But yeah, that's 6 years ago. Nowadays, your code is really good, right? But the and so like here's just like my philosophy on all this stuff. If an AI tool could replace us, then we're doing something horribly wrong, because most of what we're doing should be very creative and like actually solving human problems. Like the act of like choosing an algorithm, writing that super well, that doesn't matter by the time we choose what to write. But it's that choosing what to write that's the most important and the most difficult. So I think that like our job is going to sort of merge closer together with design, uppercase design, not like UI design, and product. And then it's going to be, okay, if we understand what the problem is, and we can our job is to communicate with the AIs to build the thing that we want to build. Which is not going to be easy, I don't think. Are you only using it for comparison? Because distance squared is frequently used if you can avoid the square root math. Distance squared is frequently used. How so? Distance squared is frequently used if you can avoid the square root math. You can't and won't discuss the fact we're teaching AI. Yeah, but they're not gonna do that on their own. Like, we're gonna have to tell them to do that. Like eventually one day they're gonna get there, but I think that kind of stuff is farther off than we think. Those are still puppets. For performance reasons, if you only need to know which of the two vectors is longer, you can just use this squared version. Oh, right. I could just do x squared plus b squared and compare those together. But I do need to know the actual distance to know whether or not it's within my sight range. So I do need to get the magnitude. So I can find out, I can get the actual distance between two to see. Yeah. So I'm going to need the true magnitude for this. So here's what I want to do. I want to get it's x squared plus b squared and then the square root of that. So I'm going to do a parentheses for these, and we're going to do self.x.how_i2 plus, yeah, okay, so now it figured that out. Look at that. Plus self.y.how_i2, and then the square root of that. So that gives me this. And then I want the distance between two vectors. So pub function distance. We're gonna have self and then other vector 2, which I kind of want to do as just a self. So other is going to be a reference to a self. We're going to return an F32. Okay, so no, don't just do magnitude again. I created magnitude so you can use it. All right, so we're going to subtract. Okay, we need to subtract each other, which means I want subtract added in here. So I want impl sub for vector 2. What? No. Type output, it's going to be equal to self. Okay, so right hand side is this self, and then we're going to get that. Okay. Then this is just gonna be, okay, self. Yep, okay. Now, can I do this with a reference? A reference to vector 2. Hold on. I'll try this again. If I do that, there we go. Now I take in a reference to vector 2. So type output. It's going to be equal to a reference to a vector 2. Now we're going to do, no. Now we're going to do a, I guess normally you would do like minus, it would take ownership of it. So maybe I will just do. This implements clone and copy. It's fairly simple. I don't know how bad it is. Our output, I want a new output to happen. So we're gonna create a new self, or a new vector 2, like that. So we're gonna take in a reference to this, and then we're gonna say self x is gonna be self.x minus x. Y is the same thing there. There we go. So then in our distance, I'm gonna create a new vector with the difference between the two. So let distance, and actually I could probably just do this in one line. We're gonna say self minus the other, take the result of this and get the magnitude. And then return that. Cannot subtract. Oh, okay, so you need to be dereferenced here. And then we're fine. Okay, so this gives me the actual distance. Then back into here, we can get the distance. So, and we have the entity size. Okay, so we need our site range for this too. So with components, vision range. All right, so then we have our entity index. So we have our entity location. We need our entity vision range. So that's entity vision range, borrowed entity locate. No, this is going to be different. So this is going to be our oh wait, this is going to have to be let's do these all together. So that can be borrowed entity vision range is equal to the So we have to do the query. So query of 0, 1, 2, 3. So 3. And then of this index, so then entity index, and then borrow that. Okay, so that gives us that. Then let our so we borrow that. Then we're gonna downcast ref. So we're gonna have our entity vision range equals borrowed entity vision range, downcast ref, vision range, unwrap. Okay. Gives us that. Okay, so then here, now that I have this vision range, we can now get the distance between the two. So we can say if our location, so entity, if a dereferenced, I think it's twice, entity location is less, no, close. Entity location is, so that distance, and then the other is going to be the dereferenced other location. Okay, so if entity location at distance, okay, if that is less than our entity vision range, which needs to be dereferenced entity vision range, then that. Oh, don't have to do a dereference there. Double. Actually, don't need to do it at all because auto dereference happens with the dot here. And then you mismatch types expected. Oh, I did only need one for a reference of it. Expected. Oh, well that's. Oh, that's fun. And then you expected F32 found struct. Okay, so you need to be double. Then, okay, so now we know they're within our vision range, which means we need to create a force away from this entity, this other entity's location. So to get that force, what I can do is I can take the other entity and subtract it from ours. That should give us essentially an arrow pointing, directly away. Then we probably need to normalize it. And then multiply by our speed. And I think that'll be enough. So we need to create our force first. So let force, it's going to be equal to, I think it's going to be quite that simple. We need to do this is going to be our other location minus our location. And I can never remember whether or not it's our location minus theirs or their location minus ours. Maybe some kind of blend and range dependence for the force. That could be interesting to make it like the closer we are, the harder we run. Possibly. Yeah, that could be interesting too. Because it's just all in here, I should be able to come in here and like change this without really affecting the rest of the app later. And we can potentially play with that if we don't like the way that it looks here. But okay, we're gonna go with the other location minus ours. So this is gonna be other location minus entity location. What are you? You're now. So you're that thing. Then I think we need to do something like that. Maybe just that. Oh, this is that thing. Okay. So that gives us a force. Now I need to normalize it. Yeah, when lots of them crowd, it'll balance out. Yeah, I want to see what just like the normal naive approach to this is gonna look like. All right, so we have this force. Now I need to normalize this. So normalizing something is basically making sure that our magnitude is set to 1. To get the magnitude to 1, we are going to take the magnitude and divide by itself. But then we also have to divide the x and a y by itself too. But we have the magnitude. So what we should be able to do, so let's see, normalize the vector. This will set the magnitude to 1. Okay, so can you figure this out? Okay, mute self, yes. Let magnitude equals self magnitude. Sure. Self.x divide equals by magnitude. Yeah, that's correct. Self.y. What was that? Okay, awesome. You figured it out. So now we can normalize this. So you need to be mutable. So now I can do force.normalize. And now I need to scale this up by our speed. So let's extract our speed here. Borrowed entity speed is going to be query. So 0, 1. Close. And then entity index, and then borrow. Okay, so that's correct. And then we're going to extract it out. So we borrowed entity speed, downcast ref. This is going to be guess just a speed. Unwrap you. All right, it gives us that. That's gonna blow up in someone's face. Hopefully not. But it might. And if it blows up, I want it to blow up early so that I can fix it for early. Okay, so where's that normalize? You normalize this, we have our entity speed, and so now I want to multiply the force by the entity speed. Okay, so back to vector 2, and let's do mole assign. So function mole assign, mute self, right hand side self. I mean that should be fine. Self.x, okay, yeah. So that should be fine there. Oh wait, no. Hold on. We want to do this for a scalar. So we can mole assign a scalar for this. That's not exactly correct. We're gonna mult assign an F32 for this. Okay, so we're gonna take in an F32. Yes. Then we're gonna do force times equals our entity speed, but we're gonna have to like extract it out. So I think it's gonna be probably just one entity speed. Okay. Now we have that. So now I want to take our acceleration and add it to our accelerations. So we have our accelerations here. Let's now in this case, this needs to be mutable. This is the only one that's mutable. So entity acceleration is equal to query of position. This is 0, 1, 2. Okay, you're correct, but you're missing the borrow mute. So borrow mute. Okay, so then let entity acceleration equals. No, we're gonna downcast mute. Okay. Personally, I prefer to do that pure, like, let force equals. Oh, okay, like, just do that all in one line. So destination minus source, normalize times what? Times, like, the speed, but you get more lines to breakpoint and check the way I did. Like, dimensionally, your force variable has changed what it is by the mutation method. Yeah, that's true. I've never really settled on one way that I really like. I just keep on like, I think every time I do it, I just do it slightly differently, and like I've not really created a super habit on like what I want to do. Okay, so now we're going to associate this. So we'd need add assign, which I think we already have. So I think what I can do is a entity, actually I might be able to use it. Entity acceleration. Oh wait, so plus equals to this force. So acceleration. So we need dereferenced. Still, that just becomes an acceleration. So double dereference. And there we go. Is Copilot useful in practice, or is still gimmicky but showing promise? So Copilot is like a try-hard programmer who doesn't know what they're doing but is trying to be really helpful. Let me make that a little bit nicer. Copilot is like a friendly dog who really wants to be helpful, like is overly enthusiastic about helping but doesn't actually know what they're doing. So they're just like, what about this? What about this? What about this? What about this? Come on, is that helpful? Am I helping? And so like to I think it's HAL 9000 without trying to kill you. That's the thing, is HAL 9000 eventually just devolves into trying to kill you by locking the door while you're out in space. It's not there yet. Although I did notice that I had to sign an agreement that if Copilot ever becomes dangerous, I should report that immediately. And then help shut it down. So there is a I suppose there's a possibility. The big thing to me, Copilot gives you a suggestion, and instead of like blindly taking it, I have to now like think, hey, is that exactly what I wanted to do? So in some ways, it's sort of like having to read other people's code while writing my own code. It kind of is like a pair programmer in the way that now a different portion of my brain is starting to be used for that. So in a way it slows me down, but in another way it like encourages me to like understand the code that I'm writing better. So actually I think as it is written right now, Copilot is a great learning tool for a programming language because it forces you to actually think about what it's trying to do. Instruct laser to cut off leg, added by Copilot. The big thing will be when Copilot then says added by this completely different person. It'll add that in. I've seen some people do some gimmicky things like, we're gonna write an entire program only by Copilot. We could try that sometime once it gets better at Rust. Right now, I don't think it will write compiling Rust on its own. Copilot comment, launch missiles to exterminate humanity and usher in machine overlord age. I mean, yeah. All right, so at this point in time, we have this going here. I think, okay. Wait, are we not using entity size? I guess I don't need my entity size. I just need the vision range. So yeah, that is probably fine. You think Copilot is a pointless idea and it doesn't even work either? I could get on board with that too for right now. Maybe in the future it'll be better. To the point where it is super helpful. It does seem to like get in the way a lot more than like more other things. Like now I haven't tried Tab 9. Tab 9 is like, when Tab 9 was released, nobody freaked out like they are freaking out with Copilot, but it's literally the same thing. If Copilot totally destroys technical interviews, I will not shed any tears for that. Which right now, supposedly Copilot is like really good at writing, at like solving what is it called? What are those like algorithms? Leak codes, yes. Copilot apparently has been just solving leak codes perfectly. So if it destroys that, I'm thinking it's gonna be fine. I'm pretty sure AI will never generate code, idiomatic code, especially not code that integrates in an existing project. Tab is different because it makes suggestion lines at a time. Well, you can set Copilot to make only suggestion lines at a time. It's a configuration setting that you can do. I think some ideas are good based on the YouTube videos they yield. That's also true. I'm gonna take the neutral stance right now and just say like I'm gonna wait until see what comes from it. Maybe nothing will come of it. Maybe a lot will come with it. Maybe more likely just a little will come from it. Let's run this and see what happens. We're gonna go into our main library. So this is gonna be repulse humans. Oh, it's like human repulsion, right? Yeah. Okay, so let's run this and see what happens. So I'm having the exact opposite effect that I want. They're attracted to each other. If humans are attracted to each other, okay, I want to do the exact opposite. So remember how I said I always do it the opposite way that I think? Yeah, I need to do entity location minus the other location. Okay, now it looks like they're being repulsed away from each other. And it's not too strong, so it's like not over not like over like not feeling like they're running away from each other, just sort of like, sorry, bumped into you. Continue it on somewhere else. Okay, so I think that's good. Let's go ahead and clean this up. So first of all, we have we have this problem. We started, finally, Clippy is now yelling at us because we have too many arguments in here. Meaning that we need a config. We need a config. So inside of our source, let's just create a config file here. Now, you have no idea what I want. Yeah, like, no. I want all of these things. Okay, so we're gonna have the arena size, which is gonna be this arena size. Strict size, context. So I don't actually need you in here. Target FPS, speed. Okay, so everything that like gets owned. And I don't even think I need to like have a new on this. And you're gonna have to be public. Okay, then in our main library, we're gonna we're just gonna convert this into that. So we're gonna just do config is equal to config. I think what we can do is just take you, move you up here, all of you, do that, you, set that, and then all of you, do that. Okay, so what do you have? You have, oh, you're not gonna tell me? So entity size, oh, is just size. That's what it is. You're just size. And we'll just set this to be like 20. Okay, and then I want to replace all of you with this config, thank you. Okay, so in main state, you are now going to take in a config. Which is a config. And so now you're gonna yell at us a lot because things like this now needs to be like config.size. So just fixing a lot of these. Okay, now what are you yelling about? Semicolon. All right, what's next? Don't need self. Don't need that. Don't need this. And then, okay, yeah, we're not using entity size, so we don't need to extract it from resources. Don't need this anyhow. Okay. So let's see if this still runs. There we go. Cleaned up everything, no warnings. Everything is still looking good, and we have 100 humans in here. So, out of curiosity, because we always like to just up things to the max, go into main. Let's try 1,000 humans. I would say that this is struggling. We're gonna have to do this in release mode. Definitely gonna have to do this in release mode. So for 1,000 of them. 100 of them is fine. Hey, but that's not too bad. 1,000 of them is still running at a pretty good clip here. So that makes me wonder, how about 10,000? I'm not feeling this one. So I think at the beginning here, it's stuck on creating all the meshes and then starting to draw them out. But yeah, this is that's not gonna work. So 10,000, how about 5,000? Wait, did I never? Oh, I kept. Okay, hold on. Okay, so 5,000 is too much also. 2,500? Oh. Was I doing like 50,000 by accident? This is not. That's not good either. Let's see. Half of this is 12.5, I think. Okay, so it's a little bit of a rough start in like the first few frames, but then it's good. So 12.5 is good for this. So I think this might be what we end up doing. We have a lot of humans in here, and then we're gonna create a zombie, and then it's just gonna start going to town and eating everybody, which then of course kills a human, and then the human has a chance of coming back as a zombie. Which will then, continue killing and eating everyone else. So, I don't think we're gonna have a. Yeah, it's eventually all the humans are probably gonna die, because the zombies never go away. They stay forever. But we don't have to worry about that. This will be incredibly satisfying if the window were resizable. I know. I didn't create that in here. I wasn't going to be part of my original simulation. We can make it whatever size we want. I wanted to make sure that like we're doing this on like screen sizes that like are easy for everyone's system at the very least. But all right, I think we're gonna call it a morning for this because we've got humans avoiding each other. So what's gonna come up tomorrow? I think, let's see, if we're humans avoiding each other, there's not much more we can do with the humans. They're kind of set. So I think now we're gonna have to get a zombie. So probably create a zombie and give it its own vision and all that good stuff. You know something I don't see? I don't see our human with the vision circle on it. That's interesting. I don't know if I'm just missing it or if it's like somehow died or is outside of the window. That might have happened. But okay, yeah, I think we'll be creating a zombie, which will be a completely different component type, which means we'll probably have to get into marker types so that we don't accidentally query for the wrong things. But that's all gonna be tomorrow. I do these streams every single weekday morning. So I'll be back tomorrow at 7 a.m. Mountain Time for about an hour and a half or so until about this time to continue working on this. So with that, I'm gonna go ahead and bring the stream to a close. I hope that you all have a great rest of your day and I'll see you next time. Bye.